Hello, everyone. Hopefully this stream should be starting by now. There we go. I'm seeing it on my end here. So we will get started. And I'm going to be doing most of these review sessions for the first few days, at least, on Coding Bat. I link this in the bottom of the video, so if you're looking for the exact lessons that I'm doing, they're going to be there. And I've also linked to the Coding Bat website. I'll just preview that really quick here. They have there's tons and tons of practice problems. Most of them are really short and give you just a quick way to practice getting Java in your fingers and thinking algorithmically. Hopefully you had a chance to look at the 4 questions that I posted and you had a chance to try to tackle them. I have not. I have just posted them. I kind of glanced at the questions, but I haven't tried to tackle these at all. So we're going to see how this goes. We'll see if I still have some good Java syntax in my fingers. It's been a little while since I've done these types of problems. So we'll see where it goes. The live chat, of course, you can post your questions there. I have a second computer running right next to me with a monitor of the live stream. So you can post questions there, and I'll try to answer them as I go. So here we go. Given 2 ints, A and B, return true if one of them is 10 or if their sum is 10. So there's many different ways that we can write this. First, I'm going to write it kind of brute force, and then we're going to think about how to refactor it to write it a little bit faster. So our first brute force method here, so I'm going to move this mic, it's going to make a little noise. So our first brute force method. So let's say this. Let me get typing here. If our first letter, so if int a, if a double equals 10, we're going to return true. Easy enough. If b double equals 10, return true. Oops, need a semicolon there. And lastly, if a plus b, a plus b double equals 10, return true. Let's see. In line 5, I have an error. 1, 2, 3, 4, 5. Oh, if else, of course. Return false. Right? Boom. We made it. So, in this case, we can do a simple brute force like this. Now, we can simplify this and make it a little bit more compact in its code, although this solution works fine. And we can do that with our simple OR statement. So we could say if b double equals 10, or a plus b equals 10, and if a double equals 10, or like this. So we could get rid of these top 2 lines. And if my syntax is right, it should still work, and we're still all correct. So the OR statement, remember, it's going to shortcut. So as soon as one of these is true, it's going to jump out, and we're going to get the correct answer. And it's going to go to return true. And recall that return kicks us out wherever we are. So we don't need an else. Yes, we could write else and have that here, but we don't need it because the return statement for us already kicks us out, and we won't get to false until we go there. I don't see any questions on this, so I'm going to go ahead and move on. This is the next warm-up. Has 10. So again, we're dealing with tens, but we have a slightly different question. We'll say that a number is teen, not 10, teen, if it is in the range 13 to 19 inclusive. Given three integer values, return true if one or more of them are a teen. So we have int A, B, and C now. Okay, so we're going to do something similar. I'm going to brute force it first just to get through the logic, and then I'm going to come back and try to clean it up so you guys can kind of see where it goes. So we can write something simple. So if A is in a range, so how can we test if A is in a range? Well, we can use our greater than or less than. So if A is greater than 12, and, right, A also needs to be less than 20. Let me make that a little bit more clear. So if A is greater than 12 and less than 20, basically if A is 13 through 19, then we can return true. Now recall, only one of these needs to actually be, we're returning a Boolean. So it only needs to return true once. Again, we can short circuit. We can just skip checking everything else if this works. So we can say if, whoops, my cursor's in the wrong spot. So if B is greater than 12 and its B is less than 20, return true. And if C is greater than 12, and its C is less than 20, not 29, then we're going to go ahead and say return true. And then we're going to say return false. Spell it right. There we go. Let's see how we did. Good. So we've got everything right in this case. We can do a similar refactoring as we did in the last one. Now, in this case, personally, I would probably leave it like this. I don't think I would change it. In part because I wouldn't want my lines to get too long. You see this little vertical line right here. This kind of shows us where typically the end of a line would be. And if I'm putting in a bunch of or statements, I could make it work, but to me this seems more clear. But let's refactor it anyways, just as an exercise. So we're going to put is A greater than 12 and A less than 20, and we're going to put or here, double pipes, use the shift key, double pipes, and we'll grab this and we'll move it up. Let's see if this editor does this. Can it do it for us? Yes, it can. Fantastic. And double pipes, and I didn't want to do that. Double pipes here. Grab that and move it up. There we go. Fantastic. We'll get rid of these two lines. And we'll go. Can you see any problems before I hit go here? We do solve this correctly. However, I wouldn't solve this like this on the AP exam. Reason being, because it's not really clear on the grouping of how we want to test this. And so, because personally I can't remember all of the operator precedences, and the and or have similar precedences, I would group everything inside of parentheses like this, so that we've got a clean understanding that you want to analyze the A's or you want to analyze B's. Oh, that parentheses didn't click there. Or you want to analyze C's. Putting the parentheses takes just a couple of seconds, but it makes it much more clear on what your intention is for analyzing this. And on the AP exam, remember, you won't really have a chance to go through and check that everything is right, like on the Replit assignments or on this. So you're going to want to group things that it's clear on what your intention is. Yes, you can use short-circuiting, but you have to rely on both your knowledge of short-circuiting and your grader's knowledge of short-circuiting, which we hope is really good. But there's always that issue that they might have, their understanding might be slightly different. They may overlook it, but by putting those extra parentheses in there, you're going to make sure that it's very clear what your intention is. And that's our key thing on the AP exam. If you can make your intention clear on what you're trying to do, even if it's not legal Java, even if it doesn't compile, you're going to get more points than if your intention is unclear. Okay, let's get into the actual exercises. So those were the 2 warm-ups. Hopefully those were pretty easy for everybody. I'll go ahead and close those down. Let's get into a real party. Tea party. Real problem, tea party. I can speak English. Here we go. We are having a party with amounts of tea and candy. Return the int outcome of the party encoded as 0 equals bad, 1 equals good, or 2 equals great. A party is good if both tea and candy are at least 5. However, if either tea or candy is at least double the amount of the other one, the party is great. However, in all cases, if either tea or candy is less than 5, the party is always bad. Okay, so this is kind of interesting. This question is almost written in reverse of how we're going to solve it. So I'm looking at this, and I'm thinking, however, in all cases. So that's a key word to me. I'm thinking in all cases. This means this is going to have to go before anything else. Whenever you see something like this that says all cases, that means don't even worry about anything else. This is the first problem you actually want to solve, even though it's the last one. And it's really hard to write a question for computer science that doesn't give really big clues on the solution. The word if, you're going to have if statements. You're going to have control statements. So we're going to have some ifs in here. Obviously, here we go. So if either tea or candy is less than 5, the party is always bad. So let's take a look. We have our 2 inputs, tea and candy, as our parameters passed in. So if tea is less than 5, or double pipes candy is less than 5, we're immediately going to return 0 and not even worry about what else is going on. We've seen this several times in our Replit review assignments where usually on part C of our longer questions, you're going to have something at the top that often kicks you out and returns either a null or a 0 or a false before you do anything else. And this is one of those cases where we have something that's, we don't even have to worry about checking anything else. And if this was an AP question, we would automatically get points for this. Okay, so if t is less than 5, if candy is less than 5, return 0. Good. Let's back up and do some more. So a party is good is a number 1 if both tea and candy are at least 5. So we can actually say return 1 here. And we already know that return 1 works because if tea and candy, if these are both true, right, then, or rather if these are both false, then this won't fire, right? And we automatically get 1. So we don't actually have to write an if statement for candy is 1. The only other if statement we need is for this one. So we're going to have an if statement here. It says if either tea or candy is at least double the amount of the other one, the party is great. So we're going to return 2. So how can we encode that? So we're going to say if t is greater than 2 times candy. We'll put some spaces in there, make it a little easier to read. So if t is 2 times greater than candy, or candy is 2 times greater than t. And we need a greater than in there. then we're going to return 2. Otherwise, the party, because we're greater than 5 on each of them, it's just going to be a good party. Let's see if I did it. Oh, we got a little problem. Let's see here. So this is double. This should be returning 1, and I should be getting a 2. So we need a greater than or equals to on these. Greater than or equals to. And there we go. Now we've passed all of our lessons. And this was my fault. This is the at least double. So at least is going to be greater than or equal to. And this is where that close reading of questions can come in. Something I can struggle with, certainly. I haven't been diagnosed with it, but I'm pretty sure I've got some dyslexia in there somewhere. So reading these questions closely and seeing this at least in there, that's going to be a big help for you. And if you have time on the AP exam, going through and making sure you catch those little phrases like at least will help you make sure you get a 5. It could be the difference between a 5 and a 4. That is Tea Party. Let's go on to the next one. This is logic 1 in order. Given 3 ints, A, B, and C, return true if B is greater than A and C is greater than B. However, with the exception of B okay is true, B does not need to be greater than A. Ooh, we've got some tricky things. So we've got A, B, C. We're going to check if they are in order. And then we've got this Boolean B okay. So let's read that one more time. However, if the exception of B okay is true, then B does not need to be greater than A. So only C needs to be greater than A. Okay, so let's think about this. There's a couple of different ways to approach this. And I think the way that I am going to approach this is using an if and an else statement with be okay. Maybe that's not the best way. There might be a more efficient way that I'll think about it, but for the moment, that's where my brain's going. So I'm gonna say this. So if be okay, and remember this is a Boolean, so I don't have to check it against anything. If it's true, then I'm gonna need to do something, and then else I'm gonna do something else. Okay. So if B okay, so if this is true, then B does not need to be greater than A. So we don't really care about A. So then I'm going to say, whoops, didn't mean to hit run. Of course I know. Then I'm going to say if B okay, I'm going to say if C is greater than A, return true. Otherwise, return false. And I'm going to say if B is greater than A and C is greater than B, I'm going to return true. Otherwise, return false. And let's see how I did. Ah, missing a semicolon. Thank you. Whoa, whoa, not there. Back up. Oh, we're missing one. Okay, so I've got one error false. 5, 6, and that's true. And I said it's false. So if C is greater than A, K is true. Hold on a moment. So this is saying C is less than 7. It's true. However, with the exception of B, okay is true. It does not need to be greater than A. Oh, I misunderstood the question. Okay, so it looks like when... I see. Okay. So the way that it's really going is it's saying that we need to see if they still work, but we're still checking if C is greater than B. So really, the only thing we really care about is C greater than B? Let's see if that works. Let's see how it is. There we go. So this is, I think, a poorly worded question. B does not need to be greater than A. It's still checking if it's in order. Really, it's only checking if C is greater than B. So that's what it was checking for. And this is what our test cases checked out for us. Okay. So that is all of the pre-given problems. We're going to jump into some other ones. So the AP exam, the two questions you're going to have are going to focus on... They're going to focus on using methods and arrays. And the methods are going to be likely... let me see here. I think I have the page on AP Comp Sci here. Our AP exam materials. If you haven't already, this testable methods PDF, I have it linked in a bunch of places. Actually, we're just going to view it right here on Canvas. So my guess is that these string methods right here, these are going to be huge. I have a feeling that you are absolutely going to have to know these, and you're likely going to have to use them in the AP exam. Find problems, go back into our labs and study these. Find the old exam materials, the old lectures, notes, all of that stuff, and learn these. You're probably going to need to know the math class as well. Absolute, power, square root, and random are likely to be on the AP exam. Okay, let's look at, I'm going to go over some of those later on in review. Right now we're going to go into array. Let's look at, and by the way, CodingBat also has this help down here, really helpful. I'm going to pick one of these at random, unless somebody has something that they want to go in the chat. Anyone? Any votes on which one I should choose? Seeing no response. So I'm going to say reverse 3. Okay. So reverse 3. Again, I have no idea what this looks like. My solution could be very inefficient, and I probably will mess up on the first run. Here we go. Given an array of ints length 3, return a new array with the elements in reverse order. So 1, 2, 3 becomes 3, 2, 1. This shouldn't be too bad. So reverse 3, we know it's going to be length 3. This makes our lives really easy. So we can say, let's create a new integer array. So int array, and we'll just call it reverse equals new int array of size 3. Whoops. Come on, not. There we go. And now we're going to need to put into that array some new items from our input array nums. So we're going to create a simple for loop. And we can do this in a couple of different ways, but I think the easiest way to do this is going to be using a standard for loop. We'll call this int I equals 0. Nope, not equal to 9, 0, thank you. And when our I is less than, in this case, it's not beautiful coding, but just to make our lives a little easier, we can say it's less than 3 since we know it's going to be 3. And we can say I++. Okay, so we have our loop set up, and we could either go backwards through our array that we created, or we could go backwards through num. Either way, doesn't really matter. What I'm gonna do is I'm going to actually create a new int here for going backwards. So because we're reversing this, one variable needs to be used to move forward through one array, and another variable needs to be used to go backwards through our original array, or vice versa. Basically, one has to go forward and the other one has to go backwards, or up the number line and down the number line, or right on the number line, left on the number line, however you want to think about it. So I'm going to call this new int. We'll call this int, we'll call this backwards, just to make it a little more clear, and we'll start that int at 2. Okay, why am I starting at 2? Because remember, our indices 0, 1, and 2. So an array of 3 is going to be at 2, is our ending index. So we can choose either or in order to reverse this. Let's go ahead and say our reverse array, and we're going to put it at index backwards equals our nums at index I. Oops. Now we do need to increment backwards, and we can do this way. We need to count it down. You can also, if you want to make it more compact, you can put this in here, not both. You can either count it down here or count it down in there, not both, because you'd be double counting. And in this way, I will count up starting at 0 index, and it will be putting that at the end of our reverse array. Then backwards will count down towards the beginning of our array as I counts up. Then we simply need to return reverse. So then we just return the array that we created. And in this way, we're able to split our array. Let's see how I did. Fingers crossed. We got it all right. Oh, awesome. So this works. This is how we do a simple reversing algorithm. I think we did this actually a couple times in class, but just as a refresher, that's what it looks like. Let's go ahead and let's just hit on the next one. Actually, you know what? I'm going to hit chance. Let's go for a chance one. Given an array of ints of even length, return a new array, length 2, containing the middle 2 elements from the original array. The original array will be length 2 or more. So we have some preconditions. Even length. So we know that we can divide by 2 and get middle 2. We don't have to worry about shifting left or right because of an odd length array, which makes life easy. We can return a new array of length 2 containing the middle 2 elements of the original array. Okay, so let's go ahead and create that new array. Int array, and we'll call this middle, and that equals a new int array of size 2. Whoops, size, come on, fat fingers, there we go, size 2. So this is our new middle array that we are going to return, and we can go ahead and just say return middle here. So for our control here, we don't really have to loop through our array. We can, but we don't need to. Instead, we can do some quick math and then just pull those two elements out. It's tempting when we're dealing with arrays to always loop, but we don't really need to because we know exactly where we need to go to. So we first need to find that middle of the array. So we'll call this a new integer, and we'll call this, I already used the term middle. Let's say mid. We'll call it midpoint. Capitalize that P. Midpoint. So our midpoint is going to equal the middle of the array. Now this is going to be an even length array, which means if we do a division, it's going to lop off that half, right? So whatever it is, if it's let's say it's an array of length 22, when we divide it in half, actually no, it won't lop it off because we won't be odd. So it'll give us 11 as the midpoint. So let's say here, midpoint equals our nums dot length divided by 2. So that will give us our midpoint number. So this is a length of 6 here, and it's going to give us a number of 3. So when we think about that, it's going to be one more than the actual middle, right? Because the middle kind of sits here at 3.5. So this is going to return 3 for us. So when we want to fill our new array, we're going to fill it on either side, or offset by 1 rather, from that midpoint. So we're going to say here our middle, and we're going to find an index of midpoint minus 1, or actually midpoint 0, getting ahead of myself, equals our nums at midpoint minus 1. And then we're going to say middle at 1 equals nums at midpoint. Let's see how I did. There we go. So why did I do this? Again, it's about this offset and thinking about starting at 0 versus starting at 1 and how division works in our integer and array world. So our midpoint is going to be the length. So length is going to start counting at 1. So this array here is 6. So 1, 2, 3, 4, 5. 6 numbers divided by 2 is going to give us 3. But then that 3 is actually going to be 1 greater, because index 0, 1, 2, 3 is going to be 1 past the actual middle of the array. And so we will need to subtract 1 from that number in order to find the midpoint position of that array. Any questions so far? Woo! We got 7 of you watching. Or I guess it's actually 6 because I'm watching myself on a separate computer here. Okay, we're going to do 2 more of these on arrays. I don't want to make this too long. We're already at about 34 minutes. And then we will resume tomorrow. And tomorrow I'll try to find some exact problems that we'll go over using string methods and using some of the other methods that will be in the AP exam. Okay, I don't see any questions, so we're going to go on to the next problem. Given an int array, return true If the array contains twice, or contains 2 twice, or 3 twice. Sorry, that's kind of weird wording, seeing 2 and twice there. The array will be length 0, 1, or 2. Okay, so we're going to see if there are repeating numbers inside of this array. And our array is only going to be of length 0, 1, or 2. And we need to return a Boolean. There's a few different ways that we can solve this problem. And I think something I might do is I would say if nums.length double equals 0, we can immediately return false. And we can actually do the same if nums equals whoops, come on, I can type. Right? You can't have a double if it's only 0 or 1 thing in there. You have to have 2. Actually, you know what? This is wrong. Pardon me. No, length is 1. Yeah, so if it's length, so if there's only 1 character, I'm thinking index, right? Even my brain gets confused sometimes with that. So if we only have 0 or 1 characters in there, we can't have doubles. So we can only have it if our length is at least 2. So if there's at least 2 characters in there. And this is a quick check at the top. Saves us from having to do a lot of weird other logic. So if we could do this a couple different ways. We could do this with a loop or without a loop. I'm going to do it without a loop because it's basically the same number of lines of code. So if our nums 0 double equals 1, or double equals 2, and, sorry, not or, and our nums 1, if I use the proper double equals 2, return true. If, and I'm sure you can see where this is going, we can take this line, copy it here, 3, 3, and again we need a default state, return, oh my goodness, I can spell it, false. Let's see how it goes. Oh, I need to spell length right. My goodness, what's going on today? There we go. So you could do this with a loop going through I less than nums.length. It would work. It's kind of redundant in something this short where you're only checking a couple of quick indices. So you don't necessarily need something. Why did I do that? You don't need something that loops through when you're only checking a couple indexes. It's unlikely that you'll see something like this on the AP exam where you have such a short index value, but you might. And in that case, you don't need an if. If you know the exact indices you're going to be working with, you don't need a loop. Okay, let's do our last review assignment for our last review problem for today. I highly, highly encourage all of you, spend some time on coding that. These problems are very straightforward, very quick, as you can see. I think we've gone through 7 or 8 of these in under 40 minutes. And they really just get you in thinking in terms of these quick algorithms and give you those chunks of code that you can use and those algorithms and the ways of thinking that will get you going for the AP exam. Okay, last one. Here we go. Given an array of ints, return the sum of the first two elements in the array. If the array length is less than 2, just sum up the elements that exist, returning 0 if the array length is 0. So again, we have this where it's kind of a backwards written question in terms of how we're going to solve this problem. So I'm going to go ahead and say, whoa, we're not in there. If, and again, we have a array named nums, if nums.length, and let's see if I can spell it right this time, double equals 0, return 0. Okay. And then we're going to say if it's less than 2, just sum up the elements that exist. Return 0 if the array is length 0. So I'm going to say, again, I could do this multiple ways. If nums.length equals 1, so if there's only one element in this, I'm going to say return the first element of nums, because that's all there is, right? If there's only one element, I'm only going to return that first element because I can't sum anything there. And then lastly, because I've gone through these ifs and checked if anything's too short, I don't care if anything's too long at this point. I know that my length of nums is going to at least be 2, so I don't have to worry about an out of bounds exception. I only have to sum the first 2 elements. The rest of my array could be a million integers long. Doesn't matter. It doesn't matter how big the index is because I only need those first 2. So I don't need a loop again in this case. So all I'm going to say here is return. I'm going to spell return right. I'm going to say return nums 0 plus nums 1. And that's it. That's all I have to do. And hopefully, fingers crossed again, yes, we solve all of those problems. Dennis has a question. I just saw that CodingBat has a section dedicated specifically AP Comp Sci exam. Do you think those would be helpful test format that has changed this year? Let's take a look, Dennis. Let's see here. We're going to go to Java. And let's look at the AP1. So let's say score is 100. Be at least 2. Yeah, this one looks good. So to answer your question, Dennis, if you guys haven't seen in the chat, he's asking whether or not this AP review section would be good for this year. So there's going to be 2 main subjects on the questions, right? You're going to have 2 questions. You're going to have one 30-minute question and one 20-minute question. For either of those questions, and I don't know what order they're going to be in, one of them is going to be about 1D arrays or array lists. You don't need to know 2D arrays. Those are not going to be on the AP exam this year. So if you see any review question that has to do with 2D arrays, I highly suggest doing it because it will help you with thinking and help you with a more complex problem. And of course, if you can go above and beyond what the exam is going to be, you don't need to, you'll have an easier time on the AP exam, rather. The other thing that's going to be on the AP exam is methods and logic. Now, they don't really explain exactly what that is, but my guess is that they're going to be asking you things like the string substring, right? How to use substring. They're going to be asking you things like using power or square root and understanding both the inputs and outputs of these different methods. That's most likely what they're going to be asking you because they know that you're going to be sitting there with this right in front of you. If you have not already printed this out, I highly recommend printing out this and having it on your desk. Yes, you can have it open in another tab, but your life is going to be a lot easier if you have this on a piece of paper. I know it sounds kind of silly in computer science to ask you to print something out, but that's going to really help you. Also, I highly recommend having these PDFs. They are a little bit beyond what the AP exam asks you for. Like there's going to be no bitwise shifts right here. But for the most part, this covers 80% of what's on these is on the AP exam. And they even have some logic stuff. So this OOP cheat sheet, if I remember correctly, this one has some logic in here. We don't have to worry about inheritance this year, but it has things just to remind you about how to instantiate classes, how to do some of that simple stuff, system.out.println. Just quick little reminders that, sometimes you can have a brain fart and it's like, what does that look like? And instead of having to take a moment to go Google what that thing looks like, which of course we know is going to be too slow during this exam. You only have 20 minutes or 30 minutes for the long one. Having just something quick like this that gives you a quick reminder of what the basic syntax looks like, what the available string methods are, how you use them, how things look in Java, just that quick little, you have that brain fart, and this helps you get past that. I highly recommend having these available. Printed is the best case, but if not, then just having them open in a quick other tab. And of course, the Java Quick Reference, because they can ask you about any one of these. All of these are available to be a question on the AP exam. Yes, everything I just showed you is linked under the AP materials page on Canvas. You can see it right here linked just below the home button on the Canvas page. So you can have all of that. I also have links to Coding Bat, Codecademy classes, Replit coding challenges that other people have written, your exam day checklist, and of course, hopefully all of you have gone through the module for preparing for the AP exam, so you know what to look forward to and how to go through that. If you have questions, again, I have links to the explainer videos, the exam day checklist, and your AP testing guide from College Board. All of that is here on exam materials page. This stuff right here from College Board, this is for all of your AP exams. So if you have other AP exams, this all applies to that. Everything below here, study materials, this is all just for our AP. Okay, everyone, we're at about 48 minutes. I don't know who L Cabin is. Just going to put some laptops next to me because you already know I don't have ink. Yeah, that's fine. Having extra laptops right now, I'm running 2 laptops. If you have your own laptop, a desktop, put your student laptop with your resources on it. Pull up your phone with resources. Of course, texting and communicating with your friends is not allowed. That is considered cheating on this exam, but you can have access to other things. Any other questions? I'll stick around for just a minute if you guys have questions, or I can go over something. If not, then we will pick this up again tomorrow. Same bat time, same bat channel. And we'll go over some of the AP questions. I will post those, the ones that I want you to look at beforehand, on Canvas announcements. All right, thank you, everyone. I will see you tomorrow.